Good morning, good afternoon, and good evening to our dear listeners who are joining us again for another exciting episode of the Eval Edge podcast. Joining me in the recording studio today are our Eval Edge hosts, Tom and Alina, and also we have excellent guests whom I will introduce in a bit. Today's session is a continuation from the webinar that was held in January, where we talked about data science, big data, and its applications or use in evaluation. And we've had several queries as a result of that webinar, people writing to us that they wanted to know more discussions. So we thought we will cover them in this podcast, largely more from a discussion panel kind of a format rather than an interview as we usually do. So joining us today are the panelists from the webinar in January, Veronica Olazabal, who is our Senior Advisor and Director of Measurement, Evaluation, and Organizational Performance at the Rockefeller Foundation. And she's also the President-elect of the American Evaluation Association. She's an award-winning evaluator with a global portfolio ranging 15 plus years, and she serves on various funding and advisory boards and has published several topics and books on evaluation. And Michael Bamberger, one of our regulars and someone we closely collaborate with, he's our independent evaluation consultant, and he possesses over 40 years of experience evaluating development programs around the world and has been working for the past few years on opportunities and challenges for the integration of big data into M&E. And he also works on complexity-focused evaluations and how data science can strengthen these evaluations. And finally, we have Peter York, who is the Principal and Chief Data Scientist for BCT Partners. Peter has over 20 years of experience as an evaluation consultant and researcher, and for the past 8 years, he has built predictive, prescriptive, and causal evaluation models using large administrative data sets and machine learning algorithms in fields such as child welfare and workforce development. So we have a great lineup to discuss that is the most important and pressing topic of our times, both whether you're a data scientist or as an evaluator. So I would like to hand over the session to Tom and Elena, who will be guiding us through this panel discussion. Tom, over to you.
Thank you, Val. That is just really very, very exciting. I mean, obviously, we had a number of conversations previously, but continuing on some of those, perhaps you could, Michael, if I can turn to you first, throw some light on what are your general impressions about the level of interest amongst data scientists as well as evaluators, and how keen do you think they are to cooperate and work together? Michael.
Thank you, Tom, and hello, everybody. I think it's important to begin by just remembering it's very dangerous to generalize about all evaluators or all data scientists. If you have an econometrics background, you'll feel very comfortable switching over to big data perhaps, but if you've been spending years doing ethnographic studies, you may find this is a completely new and perhaps somewhat uncomfortable field. So we just need to keep that in mind when we say all evaluators think this or all data scientists think that. So just a few of the general perspectives of listening to evaluators. I think the first point is many evaluators are still not very familiar with big data. They're beginning to hear about it, the interest is growing, but there's a very large number of evaluators I think have still never used big data in their work. So they're curious, some are very excited, some are a little bit suspicious, but the interest is growing, particularly among younger generations of evaluators. So we're gradually going to get this shift. But one of the areas where evaluators are interested is just trying to reduce the cost and time of data collection. This is one of the major constraints on doing evaluations. It's so expensive to collect data, you just have to work with very small samples. So there's a great deal of curiosity about how you can get much larger samples and analyze them much more quickly. So that's one point where there's just general interest, even if it's still not completely understanding all of the ways you can do it. The other thing is being able to get information rapidly for difficult to access populations. Many people are working in conflict zones, you're working with migrating populations, you're working with groups which are difficult to access either because it's dangerous or because you can't locate them. geographically remote areas. So there's a great deal of interest of how you can increase your access to populations. And then there's a lot of curiosity about new kinds of data. For a lot of evaluators, they're still not quite sure what social media analytics is, or satellite images, or phone analysis, but there's a lot of interest. People are aware that they're often having to work with fairly narrow ranges of data. So that's an area of interest. Now, people are beginning to hear about artificial intelligence, but my guess is most evaluators are still not using most of these analytical tools. But there's a lot of interest, but it's still quite a new field. And then the final area is the question of complexity. Most evaluations are not able to address complex programs. They say that this is going to be a complex evaluation, but then they just go back to doing a pre-test, post-test comparison group design. So there's beginning to increase interest in complexity analysis. It hasn't got very far yet for many evaluators, but this is seen as, I think, one of the really big potentials, particularly for people, for example, who work on things like the SDGs, where you can't escape the fact that they're incredibly complex and all interrelated. So those are a few of the points from the perspective of evaluators. And then maybe just a couple of very quick impressions on data scientists, but I'll leave to Pete and my other colleagues to go into more detail. My impression is perhaps among many data scientists, there's much less interest in evaluation than evaluators have in data science. I think a lot of data scientists don't really think they need evaluation. They look upon it as being somewhat old-fashioned, the methodologies and so on. So this is not true for everybody, but that's the impression I get among quite a lot of data scientists. There's some interest in ground truthing, of trying to check on the ground the data you get from, for example, satellite image, but it still surprises me how little. I think there's thousands of satellite image analysis where nobody ever checks on the ground to see whether the data is valid. So some people are becoming aware of this as an area of importance, but it's still not everybody. Perhaps just the final point, one area where I think that there is a lot of interest on the part of big data scientists is if you're looking at large scale social development programs where you have integrated service delivery of health, education, credit, mental health services on a very large program, because you realize you need to understand behavioral dimensions, you need to understand organizational, how services are being delivered, combined with your big data. So I think that's one of the areas where interest is growing. So this is just a very quick snapshot and reminding us that I said you can't generalize, and then I immediately went into generalizing. So we need to keep that in mind.
That is fascinating, and for evaluators, so much for us to be thinking about there: sample size, speed of data collection, access to difficult to reach populations, and engaging with complexity. That's quite a rich diet for us to be considering in the next 20 minutes or so. Pete, if I can turn to you perhaps, and thinking about cooperation between evaluators and data scientists in particular, and your experience of that.
Sure. I think that one of the key foundational elements of being able to achieve this kind of cooperation, and we'll talk later about what is the demand for this kind of cooperation between the two groups and across the groups, data scientists and evaluators. But a key thing to understand in terms of the cooperation is that there has to be a discussion really about an understanding of the philosophies that drive these two fields. And I think that philosophy affects how then can we cooperate. And it's good to know that data scientists oftentimes, and again, I'm going to speak in generalities, but we know that there are unique members of every population I'm about to generalize that this doesn't pertain to. But on the whole, as a majority, data science is really a field in which the underlying philosophy, purpose, and intent is really to get at the subjective, what's the subjective predictive experience likely to be? What's the case specific what can we learn about each case? So it's very subjective, it's case by case, it's probabilistic. The use of data science oftentimes, and again, it's not the only use by any stretch, but a lot of where the attention is right now is on really being able to accurately predict. And that accuracy is really important. And it's case specific, whether that case is an individual, an organization, or a community. Now flip that around and look at the philosophy of the evaluator. And we're looking more through an objective philosophical lens about populations. It's more macro in that sense. And validity is what really matters, the truthfulness, not necessarily predictive accuracy. And so you can see these very different philosophical perspectives, purposes, and uses for tools that creates a need to, first and foremost, in order to cooperate, we have to dialogue around what those mean, what tensions they create, in order to really get to where we can begin to cooperate. Because those philosophies do create a divide, a chasm that has to be crossed. We have to bridge, and we have to build a bridge to those. Because I think in the evaluation, if we're going to use data science for evaluation, the key is to get to that space of how can we bring more validity? How can we remove the bias? But still gain some of the benefits. And some of the other benefit that's really important from a data science standpoint is data science actually knows how to analyze using AI and machine learning complexity. So complexity is something that actually with big data science can really be helpful. But again, the challenge is that issue of predictive accuracy at the cost of bias and maybe not even having validity versus really being able to get that validity. And that tension, that bridge has to be created by really orienting each other to our philosophies. And frankly, a decision has to be made as to what's going to be the driving philosophy of the utilization of data science. And I think validity has to be ultimately that end goal.
Thank you. That's really, really interesting. And Veronica, I see you nodding there. Could you, did you just want to come in?
So building on what Michael and Pete have shared, from a cooperation perspective, I do think that there is confusion. There's confusion, as Pete just mentioned, around philosophy. There's confusion around skill set, and there's even confusion around engagement strategy. And so if we just look at skill set and zoom in, based on my own experience working with data scientists, working on projects, thinking about how to leverage data science as a tool, for example, thinking, you start to think a little bit around like the use case, not just for data science, but we're as evaluators always thinking about the use case for evaluation. And we'd like to believe that those use cases and utilization converge, but often they don't. And so here, this is what I've learned about some of the assumptions. So the first is from the evaluator side, we see that data scientists are actually not clear on the breadth of what evaluation is. From a data science perspective, evaluation to them is about experimental design. And so in a world where that is your perception and you're trained as an econometrician, for example, which is all about experimental design, so to speak, you just presume that you can do that too. So there's a little bit of a sense of a reductionist perspective on what evaluation is, and therefore how easy it is to just do it. On the evaluation side, there's a bit of a misperception around what even data science is. And we use these words like big data, we throw in machine learning, artificial intelligence, data science, which are all great and wonderful within their own rights. But we often wonder when we're engaging with a data scientist and their portfolio of projects, are they statisticians? Are they computer scientists? Are they econometricians, as Michael mentioned? So there's a little bit of a confusion, and we want to be able to box it in. But in fact, there's a breadth of experience and knowledge base there too. And then I'd say the last thing is, in working with data scientists, my perspective is, you know something about data, I know something about data. We can generate data, there's data that exists. And so we must all be on the same field around that. What I've learned is, because of what Michael has mentioned, many data scientists have not been to the actual field. They've been very much in in an insular, introverted type of platform, they actually don't know how limited information in the global south is, information around emerging markets is. And it causes a little bit of friction because as an evaluator who believes that you should know something about the data and the people in which you're working with, the values around that really drives a lot of judgment. And to Pete's earlier point, it's not just the philosophies, it's the values. On the flip side, data scientists, as Michael mentioned, are live in the world of big N for the most part, not in the world of small n. Small n is limited. It's usually categorical. Categorical data is not easy to analyze. It's qualitative. It's just different. And there's a little bit of a dismissive quality around what you can use that for. Because they've never actually gone out and realized the quality issues in some of the data sets. And so they're limited in terms of what they can analyze. And so while being able to analyze, as Pete mentioned, is the superpower really of data scientists, being able to contextualize and know something about the quality of the data itself is a limiting factor. And so these assumptions about from both camps really does drive a little bit of friction. And so while we want to converge, and while there's definitely curiosity from both sides, these philosophical and skill sets assumptions really does create a little bit of a barrier that we can talk about.
Thank you so much. That's great and really interesting. Before I bring Elena in, I just wanted to ask any of you really about your experiences of overcoming these barriers to collaboration. Are there particular examples that you've got where it's worked very well? It's been easy to, Veronica, you were very articulate about the relationship between the two disciplines and the data and the skill sets that underlie those. Have you come across particularly good ways of building those bridges? Maybe I'll start with you, Veronica, and then move on to the others.
Sure. So, as we've talked about in different fora, and as Pete also alluded to, part of the figuring out how to design the most effective relationship between a data scientist and an evaluation really starts by increasing the number of times that they're forced to work together. And so right now in the space, there isn't a lot of examples of data scientists and evaluators coming together. We have, as a collective over the years, have been involved in various different projects where we have kind of created the enabling environment to bring the two together. And so I'll speak from one example, and I think we can also speak, Michael can speak from various different examples, as can Pete. So right now, we at the Rockefeller Foundation, for example, we are very excited about the power and the promise of data and data science in terms of being able to do all the things that we've already talked about. Yeah, I call it like bigger, better, faster, right? And decision making. It's all in service to decision making. And so something that we have been trying to figure out is, well, when are those moments of connection? And so just as with about the evaluation practice, we have learned that it's really helpful to be thinking evaluatively at the early stage program project design, country project design phases. And so similarly, data scientists have been also invited to these early stage design conversations. And ideally, back to, if you put yourself in the mind of if a data scientist, you would come to the table and you would be able to apply your skill set around analyzing data. And what we have found is that data scientists are certainly being trained to analyze data, but they're not necessarily trained to think about program design. If you think about it, evaluators had to learn that too over the years. Like we started off as a very technical school of thought and have over the years diversified, and become strategic partners. And that's what we mean by evaluative, right? And so data scientists are not there yet. So when you put them all together in these early stage design processes, it becomes really clear what our various skill sets are. And so while we still have to work through the interconnectivity of how we play together in the sandbox, and I often say, who drives? I think that early stage design has really been helpful in at least playing out those processes and eventually making clear whose skill set is most needed in what area. And so, for example, evaluators are really helpful with theory of change and program design and facilitating conversations around hypotheses and surfacing indirect consequences and risks. Like, these are all the things that we do. Data scientists have no idea what any of that is and don't even place value on it. There's this presumption that those types of activities just happen. And so it actually, but people and other teams don't realize that there's a difference. They just believe data scientists must be helpful at doing X, Y, and Z, just like evaluators, and that their skill sets are interchangeable. So by bringing them together in early stage design and then figuring out roles and responsibilities clearly, collectively, we've seen that bringing that collaboration together is, even though it's forced, is more optimized. And then the last thing I'll say is, I've also seen it play out in terms of commissioning partners. So, if you work for a multilateral and are a commissioner, for example, as I am, oftentimes, you're searching for the partners and fitting them into a box, a strategy of some sort. And so not until we actually get the rubber hits the road and we actually get to searching for a partner, whether it's through development of a terms of reference or do an RFP process of some sort, and we start to interview partners, do we realize that that there's a lot of overlap in terms of what a different measurement and evaluation partner can do versus a data science partner. And often that forces a conversation around how are we going to prevent duplication and redundancy and overlap, because at some point, once you get data, you have to analyze it, and that's where I think the overlap can be. But also just clarity. It's a learning journey, clarity around, oh, this is what evaluation partners and firms and consultants can do and deliver, and this is what data scientists can do and deliver. And so increasing these opportunities, I think, will get us a little bit closer to that collaboration that we seek.
That's great. So I love the idea of it being a dance between two partners as opposed to people on either side of a chasm trying to shout at each other. Pete, you're very much experiencing this as the other partner in this relationship, as it were. Perhaps you could say about how you see collaboration working well.
Yeah, from my vantage point, what I would first of all note is I sit in a unique position in the sense that I've been a 20+ year evaluator. So I come out of a graduate education in research design, quantitative methods, in a social work school. I went to Case Western for graduate school. And so I was trained in that methodology and approach and spent 20 years doing that work. And then really it's over the past decade that been learning and integrating the tools. And that's the lesson that I think is really important to bring to this, is that the data science toolbox that's out there does not require a PhD in data science. It doesn't require a master's degree in data science. I think evaluators, as they start to learn how to collaborate, the first step is to become trained and educated on the tools, machine learning, some of the Bayesian approaches to analytics, what it can and cannot do. I think that it cannot be said enough, because in a lot of ways, what we have to do is have an evaluation field-led development of the methodologies, so that, and then the data science tools and toolbox and community can serve as a very important technical resource. So I've led numerous projects that we brought together teams of data scientists and evaluators, and as well as sort of frontline experts and stakeholders on the ground. There's a very particular way you can use existing data, but evaluators need to start to learn how to adapt their methods to those data sets. So you can actually stage different evaluations and data by generating theory, testing hypotheses, weaving in causal modeling techniques. These are all things that evaluators can use and learn, add to the toolbox machine learning, because it affords the ability, both at technological speed and efficiencies, as well as some of the tools that can address some of the pain points we have in using big data and studying and researching and evaluating programs. And I really am of the mindset that, and maybe it's because my heart is as an evaluator, I've obviously spent the past 10 years learning data science, but I speak from the heart in the sense that I believe that if we're going to have valid big data analytics and data science, the methodologies of research and evaluation, evaluators need to become educated on the toolbox and really lead, in my opinion, the methodological design and understanding of how we stage the modeling, as we call it in the data science world. And then the data scientists, I have a team that I work with that we have multiple data scientists, but they're really key resources, and they do co-lead when it comes to figuring out technical solutions to problems we're having. But the methodological framing and leadership of that work is really led by the evaluators. And so I think the big thing is we've got to start to encourage evaluators to learn about these tools, understand the difference of what we were trained on in the frequentist analytic approach, and move into the Bayesian understanding and deal with the tensions that lie in there. But I think I know there's enough work out there that we've begun to do that. And I think that collaboration is really going to require that. And then at the end of the day, I think that we need to start weaving data science education into the social sciences in a very intentional way. Because right now data science is occupied outside of our field. Most of data science is still geared towards the Internet of Things and the attention economy, and all of it driving business and commerce. So there is a select group within the data science community, but I think there needs to be some bringing together and bridging of those.
Thanks, Michael, Peter, and Veronica, for this enlightening discussion. I think this is a great stopping point for now, and we will pick up with this conversation in episode part number 2.